That's Good University.
Okay, so this week I wanted to cover the slope intercept form of a line, which you might recognize as y equals mx plus b. This allows you to calculate the y value at any point on the line along the x-axis, given that you know what the slope of the line is, and which is m, and the intercept on the y-axis, which is b. This form of a line is very important in chemistry and physics. You'll run into it a lot with the different equations that you see. So that's why I wanted to talk about it, and I'll show an example at the end. Now here on the left you can see a coordinate system with a line running through it, and the line intercepts the y-axis when x is 0, and the point is just assign some random letter b. I think it's arbitrary, I don't know if it's supposed to stand for anything, but you take a look at the line, and what we want to see is what the rise versus the run is. So how high up does the line go and how far over? So the rise is going to be the change in y, and the run is going to be the change in x. And the ratio of those two is going to be the slope. So m is rise over run, which equals delta y over delta x. What you can do is plug in what delta y and delta x are. So delta y is the final coordinate of y minus the initial coordinate of y, and same for x, final minus initial. And then what you want to do is solve this equation for y final. So we'll come up here, multiply the denominator over, so you have yf minus yi equals m times xf minus xi. And then add the y initial over, so it's f minus xi plus y initial. And then we're going to plug in our point from the coordinate system at 0 and b. So y final is m, x final minus x initial is 0, plus y initial here is going to be b. And that's where we get the equation from, y equals mx plus b. So an example of where you'll see this form of an equation is in Newton's second law, which is force equals mass times acceleration, or F equals ma. So you can see that force and acceleration have a linear relationship. So if you're trying to plot force versus acceleration, you're going to get a straight line, and the slope of that line is actually going to give you the mass. And one important thing to note is that because there's no plus b value here, that tells you that if you have 0 acceleration, you have 0 force being applied to an object, because the y-intercept is 0. So the units for force here is kilograms times meters per second squared. Mass is just in kilograms, and acceleration is meters per second squared. So you can look at how if you have your rise over run, your rise is force and your run is acceleration. So when you take the ratio of those, let's look at the units. You have kilograms times meters per second squared divided by meters per second squared. So that's F over A. And you could just flip the bottom fraction, so you have kilograms times meters per second squared times second squared per meter. and all those are going to divide out, just leaving you with kilograms. So mass is indeed your slope. Class dismissed.